Hello and welcome to today's session. Today we are going to handle the D'Alembert's ratio test for convergence. We are given a series here, and our series has terms u1 plus u2 plus, and the series goes up to un plus, and it's a series, and this series has positive terms. We are specific that it must be a series of positive terms. We are not allowing negative terms here. A series of positive terms. So what we're supposed to do here is supposed to find the expression of un. We're supposed to find un as your first step, and then another expression you're supposed to find is 1 for un plus 1. un plus 1. So those two expressions, after getting them, we're going to create a ratio because it's called the D'Alembert's ratio test. We have 2n plus 1. Now your next step, you're going to get your ratio un plus 1 over un. And what does this mean? That un plus 1 is the nth term, nth plus 1 term, n plus 1th term, whereas un is your nth term, because you see this series here goes to beyond un, so meaning you're expecting to get un plus 1 somewhere else, and then after that you get the limiting value. After getting that ratio, you get the limiting value, or in short, you just get the limit. Now you get the limiting value of the ratio. Limiting value of un plus 1 over un. Now we have three possibilities. We're going to have three possibilities. One where it's less than, one where it's equals to 1, and one where it's above 1. So we're going to have three possibilities. Now we are saying we have limit as n tends to infinity of our ratio here un plus 1 over un. If it's less than 1, then the series converges. The series converges. We have a similar limit. We are having a similar limit here. Now you're saying if the limit of this value gives me greater than 1, it shows that it diverges. It shows that the series diverges, and if this limit of my ratio here is equals to 1, then it may converge or diverge. It may converge or diverge. So either is a possibility, either of the two. So that's about the D'Alembert's ratio test. So you need to find your un plus 1, you need to find your un, find a ratio, and then find the limit, so that you can be able to tell, is this series convergent, is this series divergent, or neither. So we have an example here. We want to find out, is the series convergent or divergent? We have an example. You asked to test for convergence of a series here. 1 plus 3 over 2 plus 5 over 2 squared plus 7 over 2 to the power 4 plus, and that series is more of an infinite series. So our first step here is to identify u power n. We identify u power n, and after identifying u power n, we are saying un will be equals to, so you check here and see how this behaves. So this is the same as over 1. So you check how does it exactly behave. We're going to see from 1 to 2. So you see 1 is the same as 2 power 0, meaning 2 power 0 is equals to 1. And then our next value is 2 power 1. Our next value is 2 power 2, meaning we have 2 power m minus 1, so that if m is 0, we have negative 1. If m is 1, you're having 1. If m is 1, you're having 0. If m is 2, you're having 1. If m is 3, you're having 2. So you're going to say for the denominator it's 2 power m minus 1, because for instance here this is term number 4. We're going to have, if m is 4, let's see, 2 to the power 4 and then for the numerator we are having 2 n minus 1. If n is 0, we have negative 1. If n is 1, we're having 1. If n is 2, we're having 3. So this one is giving us 2 into n, 2 times n minus 1. And for the denominator we are having, say for this one you're going to have 1, 2, 3, 4. So for you to get the next term, for instance here we have 2 to power 1, it will give us 2 to power 0, which is 1, and then 2 to power, if m is 2, we're going to have minus 1, and that is giving us 2 to power 1, which is just 2. And if m is 3, we're going to have 3 minus 1, which is giving us 2 to power 2, like that. If it's to power 4, we're going to have 2, let's test power 4, 2 to power 4 minus 1, then this one is supposed to be cubed, and then the next value will be to power 4, so that we have 4 minus 1, which gives us 3. And now after getting u to power n, we get un plus 1. Wherever you're going to have an n, we're adding 1. If you're having an m, it means you're getting the m plus 1 term. So we're going to have 2 into n plus 1 minus 1 over the nth term is m plus 1 minus 1. Now your um plus 1 is going to be 2 n plus 2 minus 1, it gives me plus 1, and for the denominator I'm going to get 2 power m. So I have u plus n plus 1, and then I have u of n. And now I want to get the ratio as our explanation told us. Now my ratio is going to be un plus 1 over un, which gives me 2n plus 1 over 2 power n. Now I'm dividing by u of n, so it means I'm multiplying with the reciprocal. I'm going to get 2m minus 1 over 2n minus 1. Now you know the laws of indices, how they work. So we're going to have 2n plus 1 times 2m times 2 minus 1. This is to power 2m over 2n minus 1. 2n minus 1. So the 2m and the 2m are going to cancel. And now this is minus 1. It's the same as, it's 2 to power negative 1, which is the same as a half. So we're going to change this one. It will give us a half into 2n plus 1 over 2n minus 1. But now we're not done yet. Our next step is to apply a limit. So we're going to take a limit. And this limit is as n tends to infinity for our value here. So we can just still, let's write here, limit as n tends to infinity. We have a half into 2n plus 1 over 2n minus 1. Half is a constant, so we factor it out. We're going to have a half limit as n tends to infinity. And now you see here we have an n, and this is going to infinity. If we don't manipulate, we're going to get infinity over infinity, which is a definite, which is an indeterminate form. So we're going to divide here by the highest power. We will have 2 plus a half n, 2 plus a half n over 2 minus 2 plus 1 over n, then 2 minus 1 over n. But now this value here will tend to 0 because we have a very big number. We are dividing 1 by a very big number. We're going to get, the bigger the denominator, the smaller the value when you divide by 1 or any other number. So we are going to say that this one is tending to 0, the other one is also tending to 0. So we're going to have a half into 2 over 2, which gives us a half. But now a half is less than 1, so we can comfortably say that our series converges. We have our series converges. Our series converges. Thank you for joining us. See you next time. Bye.